So today's objective is logarithmic intro, logarithmic functions. A logarithmic function is the inverse of an exponential function. If you are trying to find the exponent in an exponential function, you can use the log function. So here's just an example. This is an exponential form. 3 to the second power equals 9. 3 squared equals 9. The base is 3, the exponent is 2, and 9 is your answer. 3 squared is 9. To undo that exponential equation, you would use the logarithmic form, log form, which says log of base 3. So your base is 3, so the base is here, of 9, so 9 is your answer, is 2, that's your exponent. So the base is the same, and your exponent and your answer kind of switch places. What was your answer is now in your problem, and your exponent is now going to be on the equal sign. So for example, if you had 2 to the what power equals 8, if you were trying to figure that out, we know, or hopefully you know, what power that is. 2 to the what power is 8. If you didn't know, you could use the log function, which would mean log of base 2. So your base stays the same. Log base 2 of 8. So I said right here, log base b, so log base 2 of 8 equals x. My exponent is what I'm looking for. And then if you were to figure this out and solve this, you would get 3. So x equals 3, because 2 to the third power is 8. Log base 2 of 8 is 3. So our directions say write an exponential form and log form. So I'm just trying to get you used to what in the world this stuff is, and we're going to practice going back and forth from log form to exponential form and exponential form to logarithm form. So here's the first one. Log base 4 of 64 is 3. This is written in log form. So if we wanted to write in exponential form, you're kind of going to do this, well, I'm going to show you how to do it, and then I have a tiny little shortcut. This is your base. And this, remember, is our answer. And this is your exponent. So 4 to the third power is 64. What kind of, I don't know if you necessarily call it a shortcut, but if you start at the base and you draw a little curve, what this is, it kind of shows you the progression. 4 to the third power is 64. 4 to the third power is 64. So in this one, this is your base. This is your answer, and your exponent is y. And if we do our loop, 5 to the y power is 125. We are writing this from logarithmic form to exponential form. All right, so in this one, log of 100, I don't have a base here. So whenever you don't have a base printed or written, then you're going to make sure it's an understood base 10. Kind of like if you have a square root without that little number, you know it's a square root. If you don't have the base, then you know this is base 10. And we can do our loop-de, and I know that this is 10 to the x power equals 100. Sometimes you're going to have y, sometimes you're going to have x. Sometimes you may have m or n. Just know that that is your variable exponent. All right, log base 3, and our answer is this fraction. And y is my exponent. So log base 3 of 100, 1 over 27 equals y, which means 3 to the y power is 127. Now in this particular question, because I have a fraction over here, I know that my exponent has to be some negative value in order to make my answer a fraction. Okay? Now over here, I've given them to you in exponential form, and we are going to write them in log form. Now remember, in log form, it's your base and then your answer. So right here I have my base, and then I have my answer. So it's going to be log base 5 of 125. Log base 5 of 125 equals 3. And if I want to check, if I want to work my way backwards, I just do the loop-de. 5 to the third power is 125. Over here, log base 49 of 7 equals 1/2. And we know that a half exponent is the same thing as a square root. So this should make sense. 49 to the half power, which is the same thing as the square root of 49, is 7. So log base 49 of 7 is 1/2. Here we go. I have my base and I have my answer. So log base 8 of 16 equals x. Log base of 8 of 16 equals my exponent. And this one, log base 2. My base is 2, so it's going to be the little 2 of 32 equals y. Now a word of caution. These little bases, 5, 49, 8, and 2, if you do not write those small, like a subscript, and if you don't really make it known, it's going to look like log of 5,125, and then you can get it wrong. So you have to make sure that when you write this number, it's a very little base number, and it's definitely different than this answer right here, the big number. All right, we're going to practice more. Now the last examples I want to show you today about your log intro is how to evaluate it to find that missing exponent. Sometimes you can just eyeball it, and sometimes you won't know, and the calculator will only do base 10, which I will show you later. But here's an example. Log base 4 of 64 equals x. So first you need to rewrite it in exponential form. 4 to the x power equals 64. You might know that that is 3, but let me show you how to get it. If you can simplify your numbers to the same base, if you have the same base, then your exponents have to be equal. Let me show you what I mean. I can rewrite 64 as a base of 4, because I know that 4 to the third power is 64. If you can get the same base, now I have the same base, 4 and 4. If you have the same base, then your exponents are going to be equal. That means x has to equal 3. If you can get your values to the same base, then you can find your missing exponent. Number 2, log base 5 of 1/5 equals x. I rewrote it in exponential form, which is 5 to the x power equals 1/5. And then I can rewrite it with the same base of 5. I know that 1/5, since it's a reciprocal, since the 5 is on the bottom, I know that that had a negative exponent, and it was a -1. Which means my x value is going to equal 1. All right, so number 3, log base 7 of 7 equals y. I rewrite an exponential function, which means 7 to the y power is 7. And now I need to know what this exponent is. I have the same base already, and I know that this has an exponent of 1, which means y equals 1. Example number 4, log base 2 of 8 equals y. I rewrite it in exponential form. Okay, take my marker on. So 2 to the y power equals 8. 2 to the y power equals 8. I need to rewrite 8 as a base of 2, which is 2 to the third power. Now that I have my bases the same, I know that y equals 3. So number 5 is a you try. I want you to try number 5, rewrite it in exponential form, and then work backwards to see if you can figure out what your exponent is. So 3 to the n power is 27. I can rewrite 27 as 3 to the third. So that means n equals 3. So what we're going to do tomorrow in class is we're going to go over writing logs in exponential form, writing exponents in log form, evaluating logs, and I will show you on the calculator how to evaluate it if it is a base other than 10.